Hello everyone, welcome back to my computer project. Today I'm going to test the RAM. So this is the RAM. As I said in my last two videos, it's quite cramped. This is 4 whole bytes at the moment. But I've only wired up one bit of each byte. Quick view underneath it. It's actually quite an easy board to solder. Nothing too complicated on the bottom. The only issue comes when wiring it up. So you see these yellow wires. They're the easy ones, you only need one of those per byte. But the bits, they're all tied together. And originally, like, I have diodes here, and these, get a good view here, these function as the pinouts. I cut them quite short originally, and it was actually hard tying up another cable. So what I've done is I made these a little bit longer now, so they're a bit spiky and dangerous, but it means I'll be able to use my wire wrapping tool. So I can put a wire on there, stick it over a diode that I want to. Let's find one that's not jammed. And then just tie it up, and that's easy. Then I can solder it afterwards. Just makes it easier to get on and off. Yeah. So I built a little test board here. Like I say, I've only got one bit tied up. And both the LEDs are actually the same bit. So you'll see, so there's only 8 bits, but you'll see I have 16 pinouts here. So what this is this the way you enable reading and writing. So you need access to both halves of the bit. So like, if it's one half of it is on. If it's false, the other half of it is on. So that's what these LEDs will show. They'll be able to show whether it's on or off. So, yeah. So those are tied to that. There's a little system here that drags it to the ground just to avoid any weirdness I was getting. And it also passes through a diode, just to make it more similar to what the actual read-write board would be like. It will have a diode in it. So I wanted to test it with that to make sure it's all fine. And these 4 lines here, these are the byte select. So when I turn it on, you'll see nothing lights up. But if I select a bit or a byte, you'll see that one lights up. If I select a different one lights up. And another one, that one lights up, and this one, that one lights up. So to write a bit, so these bits won't change. Like, you could do whatever you want, and these bits won't change while the byte is not selected. But if I select that, and then say disconnect this, it will swap the bit. Then put that back. Read something else. That these have all kept their state, and this one, going back to it, it's kept the state. So if I maybe do a different one. Let's write to this one. Bit of a faff at the moment, but yeah. So that bit is set. And if I go back to this one, it will be this LED here. So yeah, that's that. That's literally all I can show you with that. But my goal is now to sort of try and build a test board. So like, build a board where I can see all the see all the bits, what value they have, and write them. And another test board to select the byte. So, I mean, this is the addressing board for when it's actually in the computer, but for testing it, it'll probably be easier to just have a separate board specifically for testing, because this will be 16 bytes, which will be enough to get some programs running. But like I've said before, my end goal is to get 256 bytes. So I will need, there'll be 16 bytes on this board, like that. And I will have 16 of these boards. Now this is already quite heavy, so it's going to be a lot of boards, a lot of bits, a lot of when I said bits then I meant components, but it works both ways. A lot of components, and testing it this way is such a faff. And I've done that before with one of my registers, and it turned out there was actually a bug in it. And yeah, so I'd like to avoid that, and I'm going to build an actual testing board. Yeah, that's all I have for today, I think. I have some more video ideas planned, going over the computer as a whole, and creating an instruction language for it. So once I actually have the RAM,